So next we're going to talk about trigonometric limits. And it's important to remember that sine and cosine are defined for all real numbers and are continuous. Oops. Here we have our trigonometric identities. You will be given these on the exam, and some common trigonometric values. This is a good table to have to review back to. So the squeeze theorem is one way we can work on solving some trigonometric functions. So let f of x, g of x, and h of x be defined for all x not equal to a on an open interval containing a. If f of x is less than or equal to g of x, which is less than or equal to h of x, then the limit as x approaches a for f of x and h of x will be L, and L is a real number. Then we can say that the same is true for g. So here we have that f of x is less than g everywhere, and h of x is greater than g, and as f of x and h of x have the same value at a, it's their limit, we can claim the same is true for g. So we're kind of squeezing these things together. So here's an example with the squeeze theorem. So let's evaluate the limit as x goes to 0 for x cosine x. Now I know that the value for cosine of x is always, that doesn't even look like an x, is always between -1 and 1. And that's true for all x. But if I was to multiply both sides of this by x, I would get negative absolute value of x is less than cosine x is less than absolute value of x. So here I have my function x cosine of x. So now what I want to do is I want to take the limit of these. Of these two functions, right? These are like my f of x and my h of x. So the limit as x goes to 0 of negative absolute value of x is 0, and the limit of absolute value of x as x goes to 0 is also 0. So that means that by the squeeze theorem, we find that the limit as x goes to 0 of x cosine of x equals 0. And here are the graphs of these two functions, right? We've got the absolute value of x, negative absolute value of x, and it is squeezed between x cosine.